All right, so today we officially kick off our third project, which is super exciting. I've said, I think a couple times that this is my favorite project, just because you have some more variety than we've had in the last couple of projects. Also, I feel like this is the project where a lot of students really start to think like a data scientist, which is always good to see. It's one of the ones that I think there's a lot of obvious growth across the phase. So as an overview, very similar to the last project, when we zoom in, you're going to engage in the full data science process from start to finish, solving a classification problem using a data set of your choice. So I've said this before, but for this project, you have the option to choose a data set from the curated list, and I'm going to walk through some of those data sets very briefly, talk about some pros and cons of each. Or you can choose your own data set that's not on this list. So the goal is to choose a data set appropriate to the type of business problem and or classification methods that most interest you. And it is up to you to define the stakeholder and business problem appropriate to the data set you choose. And they recommend choosing data set 2 or 3 from this list. I do think all of them, there are different things that you can explore, but I think all of them are fine. So you do have to let me know which data set you want to pick. Either vote on the poll, or if you're using one that's not from this list, just Slack me and let me know. All right, so really quick overview on these data sets. The first one is this Chicago car crashes data. Pros and cons with this data set. For the target variable, you're going to have to engineer that a little on your own. Most students choose to predict the severity of a car accident. So whether there were fatalities or whether someone was, I forget what the exact term they use, but whether someone was seriously injured versus like minor injuries or no one was injured. So it's up to you to bin your target variable. You can do it binary, you can do multi-class as well. Binary, of course, will be more straightforward. Another thing to note about this data set, it is very big. I think this table on its own is about 400,000 rows. If your computer is taking a long time to run these models, you can definitely take a random subset. I recommend anything more than around 10,000 or more, I think is a good number. With this data set, there are actually 2 other data sets that are on the same City of Chicago website that you can get, vehicle data and driver passenger data. These actually, you can do joins if you want to consider more columns. So just for you to know, I think most people actually don't join these other data sets because there is quite a lot of information just from the car crashes data set itself. So yeah, all information that you can do what you want with. The next data set is Terry traffic stops, which is about stop and frisk data. One thing to note here, and I think it says, right, this data set includes information about gender and race. You may use this data as well, but also take into account that there has been this phenomenon of biased algorithms. And so there are a couple ways you can play around with this. First off, you can include this data to see if there are any, inherent biases in stop and frisk. Right, like if race happens to be a important feature in classifying whether someone gets stopped or not, that's something that you can use as your model, and your model will be used more as an exploration model rather than a predictive model. Or what you can do is just get rid of those variables and see if you can predict stop and frisk without those variables. So it's up to you how you want to play with it. I will say be very careful about the way that you're phrasing things in presentations. I've heard some kind of like borderline problematic things being said. So just be careful about this. So yeah, it does say here, be aware that this can make your project a highly sensitive one and your discretion will be important. More than happy to like talk through some of these things if you're unsure about it. But a very, very interesting data set, and you can really, in this data set, you can look for a lot of patterns in your data through your modeling, which I think is very interesting. So don't let that stop you from doing this data set, but just know that these are things to consider. If anyone has heard of the term weapons of mass destruction, it's basically how algorithms have built-in biases based on like things like race or gender that shouldn't be biased. So that is something to consider. The next one, which is actually, I think, one of the more popular ones, customer churn data set. I think this is from a telco. It's a binary classification problem, and the main challenge with this data set is there's this pretty severe class imbalance. So you're going to have to work around that. And with class imbalance, very typically, especially if you have majority zeros, minority ones, what you'll be looking to optimize for is your recall score. So that's going to be the challenging part with that. Otherwise, a pretty straightforward data set. And then finally, there's a Tanzanian water well data set. This is an active competition. So if you want to take up that challenge, definitely do that. If you look at the leaderboard of this competition, it is the top few, I think it's scored based on accuracy, and the top few scores are all like within like 0.0001 of each other, or 0.0, like, yeah, they're very, very close. So it's all about those incremental improvements. I think the scores are roughly around 80. I'm not too sure. You can definitely look that up on the website. But the main thing with this one is, by itself, it is a ternary classification problem, which means there are 3 classes. They are a little bit imbalanced, so you'll probably be doing Smote. But if you do want to work with this data set and don't want to deal with ternary classification, feel free to bin maybe like 2 of the variables together. That's also something you can do. Does anyone have any questions on these data sets so far? I know some of you have voted, and those of you who have voted on the poll, I've already put you into the Slack channels with my other cohort. I'm going to be posting a couple guiding questions in there that hopefully you'll answer, and those will be things that I would like you to consider per each data set. I will also link all of the Slack channels so that if you're not doing one of these data sets, you can still see what other people are talking about. So I'll do that for you all. But yes, any questions about these data sets? Cool. Now talking about sourcing your own data, and I'm really excited because a lot of you have actually sent me sent me examples of data sets that you'd like to use. I have approved a couple of you already. So sourcing your own data, the main things to look out for, that they should be appropriate for classification. Make sure that you have a column that is a target variable that can be made into classes. So one common thing is sometimes you might have a variable that is continuous that you want to predict. What you can do for this project is you could bin your variable. So for example, if your problem is whether, I don't know, maybe income, maybe you want to predict income, something you can do is maybe look for a median, and then instead of predicting income, you're going to predict below or above median income. That's also a possibility. Make sure that is usable to solve a specific business problem. Make sure that the context of your classification makes sense. In terms of number of rows and columns, at least 10 columns would be good, and roughly 1,000 rows per class. If you have some class imbalance, definitely talk to me about your data set. A lot of the data sets that people find on Kaggle have been done before. So let me know if you have something that maybe doesn't have as many rows, and I'll let you know if I've seen it before and whether those classification results are worth doing a project on. Next, make sure the data set is not one of the ones from any of our lessons. And then also manageable. You don't want something that's like millions of rows. Be careful on Kaggle. On Kaggle, some data sets actually come from BigQuery, which actually requires you to learn the Google BigQuery language to get the data. So careful about that. Make sure that they can be downloaded as CSVs or JSONs. And yeah, don't try and classify like images right now, because we're going to get to that next phase. If you are on the fence on whether you want to use your own data, there is this good, I really like this snippet in the project, what's this called? The project page, problem first or data first. So in these short-term projects, because you get to define your own problem, your problem is also constrained by what data you can find. So I think it's going to be a little bit of back and forth between like, all right, this is a cool idea for a classification project. Can I find this data? If I can't find the data, should I tweak my question a little bit, or should I completely reframe my question? So it's going to be a little bit of back and forth. So yeah, just be aware of that. That's completely normal, especially when you're made to come up with your own question. And here there are a bunch of hyperlinks to pretty good data sources. I will say Kaggle has like over 60,000 data sets available. Not all of them are appropriate for classification, but a little bit of scouring, you'll definitely find something. The UCI machine learning data sets, these are data sets that are typically good for classification. I think there's an entire section for classification too. The one downside is they are a little bit on the smaller side. So again, if it's a smaller data set, just let me know and I can let you know whether I think it's appropriate. GitHub dataset repo, NYC Open Data has a lot of city data that's available. I think projects that I've seen done using this data include things like how do people commute? There's one on like the number of squirrels in parks that I really like. And yeah, I think there's like city bike data. I'm not sure if that's from here or City Bike also has their own data source. And Airbnb data. You can actually get all the Airbnb information out of specific cities. So you can maybe classify things like kind of house and stuff like that. Deliverables are pretty much exactly the same. I'll walk through what I think a guideline of what the notebook should look like, and submission and review exactly the same. Any questions so far? All right, so same as last time, I have this project guidelines doc. Really quickly, I have the project prompt linked. This is the same thing as here. I have the rubric that I'll be using to grade you all on. And so this is in the PDF format. These are the things I'll be looking for. And also I've linked the repo setup just in case anyone needs a refresher on how to set up your repo, because this will be your first solo project. All right, so project goals: to train, test, and evaluate classification models, and also derive information from a final model to support your business case and recommendations. Something that I was really happy to see last time was a lot of your recommendations and a lot of your conclusions from your regression project were model-driven or data-driven, and that's what I'm looking for in this project as well. So example project workflow. First, your introduction to abstract. Again, this is often a section where some people come back to at the end to write, and that's completely fine. Why are you doing this project? Set up your business case, and maybe, you know, through your modeling, maybe you discover something, you can put that back in your business case as well. That's completely fine. Next, you want to import your data, clean it, do your EDA, and your EDA is going to include a lot of scatter plots and histograms probably. Here, you can perhaps ask a couple of questions about your data. Maybe you have some hypotheses about how your data is distributed. And also, how do your features relate to your target variable? So with our linear regression project, what was actually a very, very useful visualization was which features are linearly related to our target, because those will likely be better predictors. For this project, if you look at the distribution of your features with respect to their different classes and for the target variable, that is also a pretty good indicator of what will be good classification variables. So for example, if you have a continuous variable of age and you want to predict credit card default, maybe you look at the distribution of age within the 0 values and distribution of age between the 1 values. And you can have this in probably like a overlapped histogram. And if you see that distributions are quite different, it'll likely be a better predictor than if the histograms completely overlap. So consider that as well. And also, if you want to do it a little bit more scientific, you can actually conduct a bunch of t-tests across your different classes. Or if you have multi-class, you can do an ANOVA test just to see if the distribution or the proportion of data is even across the classes. After this step, you can probably do a little bit of feature engineering, do your one-hot encoding or get dummies. Remember that for every model except for logistic regression, you don't have to worry about multicollinearity, so you actually do not have to drop first when you do your get dummies. I mean, you can, because yes, the data is still embedded, but you don't have to. Yeah, before train test fit, make sure your data is now in a format that can be fed into your model, all numerical, check for NaN values as well. And then this is the same, I think this is literally the same thing I had last time. Don't do any transformations that have to do with the distribution of data before your train test it. So scaling, again, if you remember, you do your fit transform on your train and transform on your test. So at this point, you can do your train test split. And I talked about here your scaling. And then we're going to talk about baseline model. But before we get into the modeling step, any questions? Okay. So with the modeling, there are a couple approaches that I think you all can take. Most students do this first approach, and the first approach being you take your data and you throw it into every model, and then you tune your top one or maybe two models. So that's one approach you can take. Usually, if you don't really know where to start, if you don't have a good intuition of what model is going to work better for your data, that's an okay approach. So that is one approach, doing a vanilla model for maybe all of them and then picking your top one or two and tuning those. Or another approach is maybe you know what models you want to focus on, maybe based on like what you want to study or maybe models that you're just more interested in. I would say pick 4 models, which is less than half of all the models that we've learned. Pick 4 models and then tune each of them to see which one you can get to perform the best. So those are 2 main approaches through this project. Questions about that? And then I'll talk about baseline model. Okay, whichever approach you take, whether you want to do like 8 or 9 models and then narrow it down to 2, or do 4 models more in depth, is up to you. And of course, anything in between that will work as well. All right, so with our linear regression project, we had our baseline linear regression, which was our worst linear regression that we could compare future regressions to. Of course, some people's baseline ended up being the best. That's completely fine. But for this project, it's a little more hazy what you would consider as your baseline model. So I will say that it does depend. For a lot of people, especially the ones that are just going to run like all 8 or 9 models and then pick the top 2 or 1, your baseline model can literally just be your first model. Whichever first model you run, have that be your baseline, and then the idea is just improve upon that. You can also always just reorder your model, so you start with the worst one and you get better. That's completely fine. But if you want a true baseline model, scikit-learn does have this classifier that is called the dummy classifier. And just to take a really quick look, it says that it makes predictions using very simple rules. Typically, it would choose like majority class or do it just based on like probability. And this classifier is a useful, simple baseline to compare with other real classifiers. So it goes to say this is not a real classifier. It's literally just generating random predictions. So do not use it for real problems. That's what it says here. So you can see here, most commonly used strategies for this dummy classifier are like most frequent. So if you have something that's imbalanced, maybe that's what you want to use as your strategy. Also, uniform is a common one, which would basically make predictions randomly based on the distribution of your classes. Questions about this? Sorry, my charger got unplugged. So let me do this real quick. All right, yes, questions about this so far? Cool. All right, so dummy classifier, definitely something you can consider to use as your baseline. You don't have to. All right, back to this. After your baseline model or after your first model would be a really good place to determine which metrics you want to focus on optimizing, perhaps recall. Like for example, you run your first model and you have your first set of real metrics. Maybe that's when you do your breakdown of, all right, what's a false negative? What's a false positive? For the rest of the project, what should I be focused on optimizing? I think that's a good place to define that. So what's most important here is to contextualize your misclassified data. It's not always the case that if you have class imbalance, you want to check recall. It does really depend on context. So it's important to say like, all right, in this case, what's a false negative? Is it saying that someone is not going to default even though they do, or the other way around? So again, depends on how your data set is set up and also on context. And you get to decide which one you want to focus on. If it's something more similar to predicting the species of irises, likely you're going to do something like accuracy, just because I'm guessing it wouldn't matter if you misclassify an iris as one or the other. Maybe if one iris is poisonous and one isn't, you would have a preference, but I don't think irises are poisonous, so yeah. All right, so after the baseline model, again, do your modeling. Again, the 2 approaches that I mentioned are the extreme ends, so up to you how you want to do it. I would say at least 4 models, no matter which approach you're doing, at least 4 different models. So fit and test as many models. Oh, Yes.
Uh, how do we interpret, for example, false positive for ternary classifications?
That's a really, really good question. So for ternary classifications or any multi-class problem, um, usually those would be, it's very context-based. So let's say I know the water well data is whether the water well is broken, working, or in need of repair. So for each class, it will differ. I will say like for positives and negatives in a multi-class problem, it is usually a one versus all approach. So for every class, it's going to be different. So for example, in the water well problem, if you are just looking at the class of wells that are in need of repair, what is the, and let's say in need of repair is positive. A false positive would be saying a water well is in need of repair when it isn't, or false negative would be it is not in repair, but you say it is. And again, it would depend on your business problem. Like, are you going to send someone to go and repair something that isn't broken, or is your job to just make sure that water wells are safe? So you do want to send someone to make sure your wells are okay. But yeah, it is very context dependent. And if you have more classes, you would have to break that up per
So
class.
for each class, we should consider both type 1 and type 2 error, right?
Yes, yes. For each class, just like what is, for each class, yeah, what is the effect of predicting it is that class when it isn't, or predicting that it's not that class when it is?
Okay, thank you.
And I will say in different contexts, um, the effect of that would be different. Like again, like classifying, like let's say you have 5 different species of non-poisonous flowers, it wouldn't matter as much. But in something like the status of water wells, it would a little bit more. Or if it's something like medical related, it would matter more. But yeah, that's a good question. So yeah, in this modeling step, you're going to fit and test as many models. I've listed all of the models that we've gone through this phase. So feel free to pick and choose from this list. I will say most people actually choose not to do logistic regression just because logistic regression, you have to deal with all the assumptions. And we dealt with that last project. So if you don't do logistic regression for this project, that is completely okay. But if you want to use logistic regression as just like a vanilla model to throw it in, sure, by all means. And I think typically if you don't do all the tuning, it's not going to perform well anyways. So yeah, do with that what you will. I'm going to talk about this step first. At least fit the vanilla models for 4 different models, but it is up to you how in-depth you want to go before you narrow down your models. So as I said, you can do 4 models more in-depth, or vanilla models for 9 and then narrow it down to 2 or 1, or anything in between. If you wanted to do grid search for all of them, please do that if you want to. Again, reduce repetitive code by creating functions. I'm going to show you all, I think I showed you all that yesterday, maybe. Yeah, I think I did, but I'm going to talk about it again. Reduce your repetitive code by creating functions. This is just like a really good programming practice. And then finally, pick 1 to 2 models to fine tune with grid search. During your modeling phase, things to consider here: class imbalance, or would you like to maybe feature engineer something? But yeah, a lot of things to consider. But I will say for this project, most of the adjusting will be on the model level rather than on the data level. Questions so far? All right. So with your final model, definitely interpret your evaluation metrics. If you got like an accuracy of 90 and a recall of like 30 and like a precision of, I don't know, 70, what does that mean? Depending on which model you picked, you might be able to do a feature level analysis. So if you have any tree model, you can get your feature importances. If you use SVM with a linear kernel, or if you use logistic regression, you can take a look at coefficients. If you have naive Bayes, you can look at probabilities. And maybe you'll be able to do a feature level analysis to say, all right, these features contributed most to classification. And perhaps, and this is definitely more of like a level up step, if you have a lot of misclassified data, maybe do a really quick EDA on your misclassified data. Maybe there's like a common string between all of your misclassified data points that your model just isn't picking up on. That analysis sometimes can be used for just plugging into new models, or maybe you adjust your data later on. But I will say that those steps are more like next steps of future work. But simple analysis of your misclassified data sometimes can tell you about what your model is missing. Same with the last project. You can create a prediction function, again, using scikit-learn's predict. You can use scikit-learn's pipeline. When I mentioned pipelines yesterday, you can totally use pipelines as you're fitting all of your different models. I personally just like to use it at the end, just so I know, because all the parts are kind of modular, I like to just do them separately during the modeling phase anyways. But yeah, use scikit-learn's pipeline if it makes sense for you. For the prediction function, again, you have to create an array of inputs matching the feature set that your final model was trained on. That's how the predict function works. You can just, if you had 10 features, you just have to create an array of 10 numbers and you can predict on that. And something else you can check out, for those of you who have more time after this, check out Python's input function. I don't know if many of you have seen this, but Python's input function, what it does is you can actually accept raw inputs. So what you could potentially write is, let's say you want to, again, predict the price of your house and you're using like number of bedroom, bathroom, square foot. You can actually make use of this input function, and what will happen in your code, you can have your code say, how many bedrooms does your house have? And it'll actually let you input the number as the code is running. It will pause your function wherever those steps are and then take in your inputs, and you can have it do that as many times as you need. I think that resource is pretty good. It's a W3 Schools input, but you can see here, it asks for an input here. It saves X after you input. It'll literally stall your code, give you a space to input, and then it will print that. I'll let you explore this if you'd like. And yeah, after that, pretty much will just be the recommendations and future work, exactly the same as last time. Make sure that the recommendations are quantitative, if applicable, and model driven. And also, what do you learn from this model? And future work, basically, what would you have liked to do if you had more time? And finally, appendix or archives. I think a lot of you for the last project just had that in like a Scratchwork notebook. That's fine as well. Questions so far? All right, I do want to show you all an example of prediction functions, but just to go really quick, some important dates. I have set the presentation dates. I do have 2 sessions of presentations. So we're gonna do it on the Monday and the Tuesday of when we come back. And that presentation order, I will randomize it in a way that we have different projects, different data sets on both days. So yeah, I'll get that schedule out before we go on break. Again,
is this kind of like the last project where you can like continue working on it for the 2 weeks if you want to, but it's also like supposed to be a week-long project?
Absolutely.
It's feasible to do in a week?
Yeah, I definitely take the extra week if you want to. This project is definitely doable in a week, especially because I think a lot of you got really good practice from that mini project, and a lot of it is really the same process. Maybe it's just contextualizing it a little bit more with this project, but yeah, technically you can start working on it today. So yeah, should be able to be done in a week, but you have to.
Okay, and that second week, Flatiron's off anyways, right? Like
Flatiron is off. Yeah,
okay.
Flatiron is off. You'll have your channels that I will put you all in for different data sets. For all of you working on random data sets, I will post the links to the other channels just in case you wanted to like see what people are discussing. I think you know what? I'll just make another channel for all the people working on just different data sets. I'll do that. And yeah, Flatiron will be off. There will be a couple instructors just like checking the Slack channel for important questions or more time sensitive questions. So if you have like an emergency question, definitely like Slack the channel. But yeah, it can totally be done in 1 week, but you have to. And it's up to you whether you're gonna use that extra week. It is Christmas to New Year's. I know not everyone celebrates that, so do it that way you will. Cool. This doc also has a questions section shared between 2 cohorts. So my other cohort got this project at the end of last week. So they've started asking some questions and I have started answering a little bit. So this is there. They already did have another office hour on Monday, so there's already some stuff there. But all of this information is for you all to share. Cool. Questions so far? Okay. I guess since this is here, we can quickly talk about it because I didn't directly talk about Smote. With Smote, it comes from the Imbalance Learn library, so it was IMB Learn. I did see that if you have a different version of scikit-learn, it might not import correctly. So again, look for that video of mine where I talk about updating your scikit-learn libraries, but hopefully it works. If it doesn't and you can't figure it out, please let me know. When should you do Smote? So Smote, how it works on solving your class imbalance is Smote creates synthetic data points on your minority class. So imagine you had like a blob of your majority class here, a blob of your minority, actually, let me just draw it out. If you have, and let me get some stamps over here. All right, let's see if this works. All right, so let's say you have your majority class of stars all over here, and let's just like spread it out a little bit more. So this is your majority class, and let's just say your minority class is somewhere like here. So a little bit separable, some overlaps. What Smote does is it looks at the area of your minority class, which is around here. Of course, does it better in like multi-dimensional space. And then what Smote does is it creates synthetic data within that space. So here our X's are our actual points, but here you can see Smote will just create additional data points within this space to balance out your data. So that's how Smote works. Remember that it's synthetic data. That data is not real. But when you do a Smote dot, I believe it's not called fit transform. I think it's called fit. It's called fit something else. I don't remember right now off the top of my head. But fit resample, I think is what it's called. So when you do your fit resample, remember only do that on your training data. Again, you don't want this to be influenced by your test set. And then when you are testing your model, when you're getting your predictions, you actually don't do that on your smoted data, because why are you making predictions on synthetic data? You only need to do that on your unsmoted sets. If that's not clear, feel free to, I'm happy to talk about this again during like an office hour or during one-on-ones. But in a nutshell, that's what Smote's about. Questions
Quick question about like if you have unbalanced data and you want to do under or oversampling, is there a minimum number of observations you need, like 1,000 or?
I will say like around 1,000 per class is a good place to be for just, you know, for models to have things to learn from. If you're like hovering around like 700-800, that's fine. I've seen projects be okay with like 500 as well, but of course the more data the better. But yeah, if you're over or undersampling, and again, undersampling would be like, if I only had these X's, I'll just randomly sample some of these stars to match number of X's. You will end up with much smaller data, usually, depending on like how severe your class imbalance is. So typically Smote is preferred because it's better to have more data than less. But yeah, if there is a number, I would say try to hit about 1,000. Again, it is very case by case. So if you do want to talk about like what your numbers are looking like based on your different methods of resampling, just let me know. Cool. Anything else? Let's see what else is on this so far. So during tomorrow's study group, I'm going to be talking about object-oriented programming, and that's where I'll also talk about scripting. So this part won't make sense right now. I'm going to talk about object-oriented programming, and then I'm also going to talk about how you can put your functions in Python files and then import them into your notebook so you don't have like a bunch of functions in your notebook. You can actually store your functions in a separate file, which will be pretty neat, and will also make your notebook neater. So yeah, that I'll address tomorrow. But cool. Any questions so far? I do want to show an example of a prediction function.
The data sets themselves, do we just follow the links in the document to get to? Okay, and we have to download them from Kaggle or wherever. Okay.
Yep, I think all of them, I did do a check a couple weeks ago. I think all of them do have direct CSV download links. All right, anything else? All right, okay, so I wanted to show you all an example of a prediction function. Unfortunately, the last time I did this, I did not actually output something, but this is kind of what a prediction looks like. So you can see here, again, this was my text classification example. And with that, I had it taken a raw text and I had it pre-processed. And all this pre-processing, you can sort of think of it as like rescaling your data and doing like the Smote. No, actually you won't do Smote in predictions, but this was all the pre-processing I had to do. This was text data, so I had to do a bunch of cleaning. I also had pickled, you can sort of think of this as like a scaler, but yeah, I pickled the scaler just so I could use it in this separate notebook. But yeah, it calls on this pre-processing function, and then this is my model, MNB here, and it can make predictions on basically any text that I fit into here. And what's good about this, and why I think it's a good idea to practice doing this, is if you ever want to productionalize your model or turn your model into an app, this is kind of the format you need to get your modeling prediction function down to. Questions about this? What I will show you, I actually have two versions of this. One version that I like to show students, one that is more for fun. I couldn't find the student version, so this is more of a funny one. But I built a classifier to basically predict whether there is, fans of The Office would know, like, if you can say like, that's what she said in response to something that someone said, I built a classifier to classify that. So it's basically like an innuendo detector. And I made it into a web app. You can actually find this on the internet, which is pretty funny. But what you can do is, these are also not mine. These are my friends' inputs. So for example, if I just put like a random phrase, like that was mediocre, they will basically classify whether it's innuendo or not. And I can do this because I made it into a function. And I'll also walk through how to build a mini website like this for your projects when we get to capstones. But if I submit this, it'll take a little bit of time because I haven't run this server in a while. But when I click that, it will classify that text. And it can do that because I created that prediction function. So that's why I highly recommend you try doing that. So that was not an innuendo text. And just an example of something that is, it'll take a little bit of time to load because I'm hosting it on a cloud platform. That's not as important. But yes, any questions? Very important to create this function, at least not for now, but it'll be very beneficial for later on. Because if you ever wanted to put your project up on a web page or create like a mini app for it, or just have other functions call on your function, you need that format.
So you don't use the pipeline at all when you're creating this predict function here, but you could, couldn't you?
Yeah, I definitely could. Again, I did this like over a year ago, I think. So yeah, I could have definitely put all of these steps, because here I'm doing a dot transform. Yeah, here I'm doing a dot transform. I don't have a scaler for this one, but the dot transform could have been done in a scikit-learn pipeline for sure. Yeah, so any questions on the project overall? Cool. As you vote on the poll, I will be putting you all into the respective channels. And I'll also post, again, like I'll post the links to all the different channels so you can just see what other people are talking about if that's interesting to you. Yeah, I think that's all I have for you today. Remember, tomorrow we're going back to section 21 on object-oriented programming. Might be useful for you. So yeah, that's what we're doing tomorrow.
Do you have a summary of the different types of models that we've gone through so far?
Yeah, still on its way. Haven't had too much time between meetings to work on that. If anyone wants to do that, I think it would be a good revision technique, but I am also working on my own version.
I'm gonna do it for my blog. If I do it, I'll send it to you guys, but I don't want to commit to that yet.
Awesome. Yeah, I think it's a good way to just summarize the entire phase. I am also like not going to go into like a lot of detail into that. I'm really just going to list all the models, things to consider, what information you can extract. So yeah, hopefully, I don't know if I can do it today, but hopefully tomorrow. But yes, that is coming. I know I said early this week, but early this week is over. But yeah, anything else? Cool. Well, if there's nothing else, I will see you all at your one-on-ones or at tomorrow's study group. Definitely a good time to start working on the project. Let me know what data sets you're working on ASAP. And yeah, have a good rest of your day, everybody.
Thank you.
All right, bye.
Bye.